We will continue with the second part in this video. Now we will draw the cam profile. So here the height of the follower, maximum height of the follower is 30 mm, and the radius or base circle radius is 30 mm. Angle of ascent is 120 degrees. The first dwell is 30 degrees, and the angle of descent 5d is 90 degrees. N is speed of the cam is 800 rpm. And the second dwell, if we calculate, it will come to 120 degrees. Now, and also the cam is rotating in counterclockwise direction. So if the cam is rotating in counterclockwise direction, the profile must be drawn in clockwise direction. If the cam is rotating in clockwise direction, the profile must be drawn in counterclockwise direction. So that point must be remembered. Now, because since the cam is rotating in counterclockwise direction, we will draw the profile in clockwise direction. Okay, now we will take the same scale which we have taken for drawing the displacement diagram. You have to take the same scale. So there we have taken the scale as it is 1 centimeter is equal to 5 mm. So we have RC, radius of the base circle, as 30 mm. So we take radius of 6 centimeters now. So 30 mm means it will come to 30 mm will be equal to 6 centimeters. So take now radius r equal to 6 centimeters and draw a circle like this. Then from the center you draw one vertical line. On it you draw the follower as shown here. So we have drawn a circle and then the follower. Now the angle of ascent is 120 degrees. Now we have to draw the profile in clockwise direction. So from this line mark 120 degrees as the first segment, that is for the angle for the ascent, that is the angle of ascent. So we have to mark the angle of ascent. So we mark an angle of 120 degrees and extend the line outward. Okay, now this angle is 120 degrees. This is 120 degrees. Now we have to divide this 120 degrees sector into 6 equal parts, because here in the displacement diagram for the ascent, angle of ascent, we have divided the displacement diagram into 6 equal parts. So this angle also must be divided into 6 equal parts. So we will draw the first part, extend it a little bit, and the second part, extend it a little bit, then the third part, and we have the fourth part. And fifth and sixth part. Now we will mark the same numbers which we have marked in the displacement diagram. So we have divided the displacement diagram for ascent into 6 equal parts and numbered 0 to 6. So we will use the same values here. So starting from 0, then 1, 2, 3, 4, 5 and 6. Now transfer this length 1 dash. So this is 1 and this is 1 dash to first line on the first segment. So this, let this be the 1 dash, this be 1 dash. So this 1 dash length must be equal to this length 1 dash must be equal to this length 1 dash. So take this length using a compass and transfer it on this line here. Okay, now similarly take a compass and adjust to this length 2 dash and transfer it to this line, that is 2 dash here. It will come somewhere here. So mark 2 dash here. So let us say this is 2 dash. Then similarly take the length 3 dash and mark it on this line. So 3 dash. Then take the length 4 4 dash and mark it on this line. Okay, so 4, no, somewhere here we will have 4 dash. Okay, now measure 5 dash using a compass. Take this length and transfer it on this line, 5 to 5 dash. So it will come somewhere around here. This is 5 dash. Then finally measure this length 6 dash using a compass. Take this length, then mark it on this line. So if you start from here, from point 6, so 6 dash will come somewhere here. Okay, so 6 dash. So we have marked the points for the ascent of the follower. Now we have a dwell for 30 degrees. Okay, here we have a dwell for 30 degrees. So once the follower reaches the highest point, then for 30 degrees of rotation of the cam, the follower must stay at the top position. Okay, so now we will mark the 30 degrees dwell here in this circle. So from here you mark a angle of 30 degrees and just draw a line here. So we have marked a line of 30 degrees. So this is 30 degrees. So this is the dwell. Now in the displacement diagram we see that after the dwell we should mark the same number 6 here, and if we have 6 dash here, we have 6 dash here also. So we take this length 6 dash and mark it here. So here the number must be 6 again. So whenever there is a dwell, you continue with the number which was previously there in the there before the dwell. Okay, so before the dwell we had the number 6. So after dwell also you continue with the same number. And now measure the length 6 dash. It will be same as this length, of course. So that you transfer it on this line. Okay, so it will be somewhere here. So this is again 6 dash. Now that is the dwell. So we have marked the dwell. Next, now we will have the angle of descent. It is for 90 degrees. So now we have to mark an angle of 90 degrees starting from here. You mark an angle of 90 degrees. So that we will do it now. So this is an angle of 90 degrees. Now the angle of descent has also been divided into 6 parts here. See, we have divided the angle of descent into 6 parts. So this angle 90 degrees, which is the descent of the follower. So this is 90 degrees. So this sector also must be divided into 6 equal parts. Okay. So now we will divide the first segment. The second segment, and the third segment, the fourth segment, and now the fifth and the sixth segment. So now we have divided this also into 6 equal parts. Now we begin marking here. See, the numbers here are starting from again 6, 7, 8, 9 up to 12. So we already marked 6. Now we will mark this number here as this will be 7, then 8, 9, 10, 11 and 12. Okay, now again similarly transfer this 6 dash is over. 6 dash is okay. 6 dash is over. Now 7 dash must be transferred here on this segment. Okay, to transfer it on this line, this height of the follower, 7 dash. So it will come somewhere here, 7 dash. Then transfer this segment 8 dash, this length using a compass onto this line. 8 is here, you mark 8 dash somewhere here. So you mark 8 dash. So that will be 8 dash. then 9 dash, then mark 10 dash on the line, on this line, dash, then mark 11 dash, 11 dash on this line, that will be 11 dash, so we have 12 and 12 dash will overlap. Now we will join the points using a smooth curve. Okay, so we will join. So you, by free hand, you have to join this curve points and form a curve. So this red line is the profile of the cam for the given motion of the follower. So the follower rises with constant acceleration for the first half of the ascent, then for the remaining half of the ascent it rises with constant deceleration, then it comes down or it returns with a simple harmonic motion. So this red curve which we have drawn is the profile of the cam. So this is how we draw the profile of the given cam. Now we calculate the angular velocity. It is 2 pi into n by 60. N is 800. So omega will come to 83.77 radians per second. So that is the angular velocity of the cam. For maximum acceleration ascent, Vmax is equal to 2 into h into omega by phi a. That is equal to 2 into 0.03 into 83.77 divided by angle of ascent is 120, multiply by pi and divide by 180 to convert it into radians. So from that we will get Vmax is equal to 2.4 meters per second during ascent of the follower, and the acceleration is uniform acceleration. So the ascent of the follower is by uniform acceleration. So we have acceleration F is equal to 4 into h into omega square by phi a square. So that is equal to 4 into 0.03 into 83.77 whole square divided by 120 into pi 180 whole square. So that will be equal to 191. It's 191.97 meters per second square. So that is the acceleration, uniform acceleration during ascent. Now we will calculate the velocity, maximum velocity during descent. Now during descent, Vmax is equal to h by 2 into pi omega by phi d. All these formulas we had derived or written while learning about the displacement diagrams of different types. So this is displacement descent is with the simple harmonic motion. So for simple harmonic motion, Vmax is given by this formula. So that is equal to 0.03. So h, we are converting it into meters. So 30 mm by 1000 is 0.03 divided by 2 into pi into 83.77 divided by 5d. 5d is again 90 degrees, descent is 90 degrees into pi by 180. So this will be equal to 2.51 meters per second. So that is the maximum velocity during descent. Now we will find the maximum acceleration F max during descent. So that is equal to h by 2 into pi omega by 5 d, of course 5d whole square, that is equal to 0.03 by 2 into pi into 83.77 by 90 into pi by 180 whole square, and this will be equal to 421.04 meters per second square. Sorry, meters per second square. So that is the acceleration during descent. So basically we have drawn the profile here and found the maximum values of velocities and acceleration during ascent and descent. So the displacement of the follower is different during ascent. It is the follower during ascent rises with a constant acceleration motion, and during descent the follower comes down with simple harmonic motion. And the profile also we have drawn. So that is the end of this video.